So hi everyone, my name is Yukan Lafi, and I am going to talk about the introduction of our digit project. So, the brief introduction of flip-flop. So a circuit known as a flip-flop holds its condition until an input is received that instructs it to change. You may build a simple flip-flop with 4 no or 4 NAND gates. A common term for the fundamental digital memory circuit is the flip-flop. Its two conditions are logic 0 low and logic 1 high. A flip-flop is a type of sequential circuit that only has one binary state of data or information. So there are 4 types of flip-flops. So the first one is SR flip-flops, number 2 is JK flip-flop, and number 3 is D flip-flop, and the last one is D flip-flop. So the next one, I'm going to talk about the counter. So counters are specifically designed sequential circuits where the flip-flops count is maintained in the circuit equal to the counter state. Counters figure out or record the quantities of times an event happens. Mode exists for counters. The counters mode indicates how many states it has cycled to before beginning to its starting state. There are 2 types of counters available for digital circuits, synchronous counters and asynchronous counters.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Muhammad Hidayat Mustaqim bin Iswadi, and my matrix number is AA230050. And for this one, I will be explaining on how we are doing task A. Okay, for the question, firstly, design a Moore machine using 3 JK flip-flop for a transition state diagram with your own design of counting sequence. Show all the steps and draw the resulting circuit, then construct and connect the circuit using IC 7374 flip-flop and other logic gates interconnect. Okay, first of all, through this table, through this picture, you can see that the first is we must make the diagram, and the second, through the diagram, we can make the excitation table. For this one, we will refer to chapter 7 to do this. After that, after finish doing the excitation table, we'll make a circuit on a logic sim. And the next picture is about the next circuit that we make as a simulation in a Tinkercad. As you can see, we are using OR gate for this project. That's all. Thank you.
Assalamualaikum, my name is Muhammad Afizi. Right, for discussion for task A, designing and simulating a Moore machine using 3 JK flip-flop, IC7473, and OR gate is a brilliant way to combine theoretical knowledge and practical implementation in digital electronics. The discussion focused on the crucial aspect of design process. Challenges encountered and observations are made during the simulation. The first thing was to define the state together with the required counting sequence. To do this, an 8-state binary counting sequence was used. The first step involved defining an state and the desired counting sequence. For this task, an 8-state binary counting sequence was chosen from 000 to 111. Such a design is simple, as many applications and thus is well suited for demonstrating and how a Moore machine works. That's all.
Assalamualaikum, my name is Ahmed Iskandar bin Kamisan. I want to talk about the task for task B. The discussion for task B. So we build the test 4-bit parallel in looping shift register circuit using 7476 JK flip-flop in this logism simulation. After first entity out, all flip-flop and turning off clear input. We observe and verify the result by feeding parallel data into the flip-flop first and then turning on clock pulse to start the shift process. Data move through the register to the right with the final return to the initial flip-flop, confirming the function. To confirm that with the simulation correctly mirror the periodic behavior of the 4-bit shift register. We carefully observe the verify each step of the shift register operation. This allows us to test the shift register design and operational integrity inside the Logism digital logic framework. Thank you.
This is how we do the simulation. First tick once and tick enable, and then put the input 1 clear, input press 0 and clear to 0 and press enable. Okay, that's all.
Okay, lastly, for the conclusion. From both every activity that we have done is the JK flip-flop is a versatile and widely been used in a digital electronics. And we know that the JK flip-flops is also a reliable digital circuit component. It is capable of set, reset, and toggle functions, which eliminates certain conditions, and it's widely used in applications requiring precise timing and control. It's also synchronously with the clock signal, meaning that change to the output may occur only at clock edge, providing precise control over timing in digital circuits. It is also having the ability to perform as a set reset flip-flop when J and K are different, and as a toggle flip-flop when J and K are the same, makes the JK flip-flop highly versatile for various applications including counters, shift registers, and memory storage elements. That's all from us. Hope you enjoy it.